this segment here. I'm going to take this part here. Okay, this is the part I'm going to take. It's the one we are going to start discussing about. As long as you will be doing physics semester 1 and semester 2, you need to know this. Okay, so this is our next part now. So we know this is our vector A. Okay, this is our vector A. Okay, and these are its component. We have the x component and the y component. Okay, so now as you can see now, this vector is at an angle. Now these two, the components and the vector, has made an angle which you are going to call theta here. Okay, in this case, this theta is called direction. The angle on vectors is what we refer to direction. So when you are asked to find the direction, they are asking to find the angle. Okay, so what I want you to recall the concept on Pythagoras theorem, where we used to talk about okay, let me first go ahead and talk about trig ratios, where we used to apply SOHCAHTOA there. Okay, we used to apply SOHCAHTOA. I know by now, guys, you are familiar with what this means. It means this SO SOH is sin theta over opposite over hypotenuse. Okay, then this part is same as cosine theta here over adjacent over hypotenuse. So if you have been given the right angled triangle, this is the right angled triangle. Okay, the hypotenuse is this side, which is the what? Which is the longest? It is the hypotenuse. And the opposite, it is the one which this side which is opposite to the theta here. And this side which is opposite to this, it is our y component. So this is our opposite side. And the adjacent side is this part. I know no one can have challenges with this. No one by now. So now we need to find the formulas of how we can find the
Question.
go ahead.
Now, what if the theta is on this 90 degrees, this right angle triangle? The opposite is going to
Oh,
be
we are
this
not
right
going to
angle.
consider it. We're going to consider the theta which is in between the vector and one of the components. Okay, this one is between the two components. This one we are not going to consider it because our main focus is on this vector. Okay, so now let's go ahead and find the formula of how we can find the y component. Okay, to find the y component, you know that the y is the opposite here. So we're going to use this part here. Okay, we're going to say sine theta is equal to opposite over hypotenuse. So our sine theta is equal to our opposite side, guys, is our y component. What about our hypotenuse? Our hypotenuse is A, which is the magnitude of A. Okay, so to solve for y components, we cross multiply there. Okay, we're going to get our y component is going to be our A sine theta. Guys, know this formula, I beg you. Know this formula. It is something you need to study today without sleeping, without without letting this information go away from you. You need to know this just for today. Okay, so now let's go ahead and find the formula for the x component. Since the x component is the adjacent, we are going to use the cosine theta adjacent over hypotenuse. Okay, so we're going to say cosine theta here. What is our adjacent? Our adjacent is our ax there, which is the x component of vector A. Okay, now how can we find the y component? I mean the hypotenuse here. The hypotenuse is the magnitude of vector A. To solve for x, as usual, we cross prime. Okay, we are going to get our ax is going to be a cosine theta there. I'm even enclosing this into boxes so that you know that they are very important for you. Okay, now let's go ahead and just remain with a few minutes. So we are just going to end maybe on explaining, then the questions, I'm just going to send a video. Because the session will only last for 2 hours. So, what else now do you need to know? Let's go ahead now. Since we have the two components, we can find vector A. Okay, because these guys which we are using is not vector A, it is the magnitude of vector A, the size of vector A. You're going to understand this when we start doing some questions. So, using Pythagoras theorem, vector A is found by this formula. Even if I don't show you where the formula is coming from, let me just show you the how to find the formulas in a simple way without you struggling. Okay, then ay squared. This is making sense when you were using Pythagoras guys in grade 8. This is how you used to find the hypotenuse. You used to square this, you also square this, then you find the square root of that. So this is what we're actually doing to find vector A. So whenever you are asked to find the magnitude of a vector, use this formula since you have already been given what, the x and the y components. Okay, so now let's go ahead and find the formula to find the direction. How can you find the direction now? Direction is the whole is the we are going to use this part. Okay, we are going to use this part since the direction is opposite to the what, is opposite to the y component. We are going to use this part. Okay, we are going to use tangent. So we're going to say tan theta there. Tan theta there is equal to opposite over adjacent there. So our tan theta is equal to, our opposite is our y component. Here is our opposite. And our adjacent is our what? Our x component. So now, to solve for theta, guys, we are going to say theta is equal to tan inverse. This is how, instead of dividing, we don't divide in when we are dealing with the trig ratios. We just say tan inverse of x component, y component over x component. So this is how, guys, you'll be now. This how many formulas now so far? We have 4 formulas. Know these formulas, guys. If you have to know these formulas just today. Okay? Don't sleep without knowing these formulas. Anyone with the question?
What is it? Then
Cook egg.
it's
So there is no question. That means
No,
you
there is
guys.
no question. That means
Is there any question?
Is there any question? No.
All right. So now this is the question. Calculate the x component and the y component of vector with magnitudes. Okay, so we're going to rate this to be vector A. So magnitude is going to be 24 there. We've been given 24 meters. Okay, then the direction here is theta. Okay, is 56 there. So we are asked to find the x component and the y component. As usual, the x component, now you know that the x component is going to be a cosine theta. You already know the formulas, guys. So we just say our a is 24, then cos 56. Okay, what is the value? Someone to give me the answer.
13.
13.42
Okay, 13.4.
062
13.4. It's okay, we can write 13.4 there, meters. So our y component now is to be our a sine theta there. Okay, where our a is still 24, then sine what? Sine 56. How are we going to find our y component? Somebody to give me the answer.
19.8969.
How, how much?
19.8969.
19.89.
Yeah.
So
690.
19.9. Let's write it as 19.9. It's you guys who are giving me these answers. Okay, so this is how you find the y component there. Okay, what about question 3? Question 3 now we have been given, okay, we have been given vector A, which has component x components. Okay, I've been given the x component there to be negative 5 meters, and the y component to be 9 meters here. So the first question is to find the magnitude and the direction of vector A. So to find the magnitude, guys, of vector A, we use the formula there. We are using this formula, ax squared plus a y squared there. Okay, so now how are we going to find? We are going to replace the given values. We replace the given values. We are having our ax is negative 5 squared, then 9 squared there. Okay, what is the answer, guys? 5 squared plus 9 squared. It's giving me 106, then square root of 106. Okay, it's giving 10.3 after I round it off. So it's 10.3 meters. So this is the magnitude of vector A. What about the direction? The direction, we use the formula. The direction is equal to the inverse tangent of the y component over the x component there. Okay, so the tangent inverse is equal to our y component, guys, is 9, and our x component is going to be 5. We don't include the negative in this formula. You'll be confused. Okay, there is a part where we are going to learn very soon, which is going to make sense of this. Okay, so the tangent inverse of 9 over 35 is giving, so we say the tangent inverse of 9 divided by 5 is giving us 61 after rounding off. It's giving 61. Okay, but here, guys, I'm going to explain you why this is not going to be the answer. Okay, this answer, guys, is not going to be the answer because we are going to follow the quadrants. I'm going to teach you very soon about quadrants. So from now, just understand that if x component is negative, as we have negative 5 here, if x component is negative and the y component is positive, that means the angle is in the second quadrant. And to find the angle in the second quadrant, well, we subtract the angle from 180. So I'm going to say 180 minus 61. So our answer is going to be something like 119 there. This is now our direction. So the reason why this is not going to be the answer, just accept the fact that the x component is negative and the y component is positive. I'm going to show you the meaning of this very soon. Okay, from now just know that. I think there will be no question on this part. Just you guys know the formula. This is a basic question, very basic. There are some questions which are difficult on vectors. Okay, so now I come now on other part on how to find the direction of a vector. Okay, how can you find the direction of a vector? Here's how to go about it. Okay, so with the point which you are going to get, guys, just know that we measure the vector from the positive x direction. Okay, from the positive x direction. This is the first point you need to know. The other point, we can measure the vector clockwise. I mean the direction, we can measure the direction clockwise or anti-clockwise. So guys, clockwise, we just follow the way the clock moves. The clock moves in this direction. Okay? This is how the clock moves. So the anti-clockwise is the opposite. Okay? That means now the clock anti-clockwise, we will be measuring angles in this direction now. Okay? Yeah. The first fact you need to know that we measure angles from the positive x direction. The positive x direction is here. This is our negative x direction, and this is our negative y direction, and this is our positive y direction there. Okay, so let's say for example we have been given vector A. Okay, I'll be using this to be vector A everywhere. Okay, and you have been given an angle here, 20 degrees. So this angle is not the direction. We are going to find the direction after we measure that angle from the positive x direction. Okay, so what we do, we are going to start from our positive x direction here until we reach where the vector is. So the first part, you are going to move anti-clockwise. Okay, we are going to move anti-clockwise. We are going to move this. So we reach where the vector is. As you can see now, from here to here, we have just have 20 degrees. Okay, so in this case, the direction is just 20 degrees there. What about anti-clockwise? Anti-clockwise means to say we are still starting from positive x direction. Okay, we are starting from positive direction, but we are going to move clockwise direction. Okay, this is the anti-clockwise we were measuring. So we're going to move now clockwise direction. We're going to move from here all the way to where the vector is. So now to find this angle, okay, to find this angle, as you can see, this is almost making a 360 degrees. So what you are going to do to find the direction now, you are going to say 360 minus the 20 here which have been given, and our theta is going to be 340. Okay, so the direction, you can use this, you can also use this. It is one and the same. If you have been asked to use anti-clockwise, you measure 20 degrees. If you have been given clockwise, you see you have been asked to say measure the direction clockwise directions, you use 340. It is one and the same. Okay, for you guys whom we had the first lesson together, I asked you to test cos 20, okay, and cos 340. These things are going to give you the same answer here. What sometimes may differ is only the direction there, the negative sign. So cos 20, when you say cos 20, cos 20 is 0.9. Okay, it is 0.94. What about cos 340? Cos 340 is also 0.94. So this makes more sense, guys. Okay, so finding the direction clockwise or anti-clockwise doesn't affect the direction. It is one and the same. So what you need to know, guys, if you haven't been instructed the direction to use, go ahead and use anti-clockwise. It is the recommended. You use clockwise only if you have been told to use clockwise. Okay, we still have more examples you are going to understand here. What if now this our vector here, our angle is here? Go ahead and find the direction here. So clockwise, guys, clockwise we are going to move this direction from the x, because our positive x direction here, that's where we start. We move from all the way to where our vector is here. So now this direction, here is how we are going to move. From this point to this point we have 90. Also here we have 90. Also here we have 90. So this segment here we also have 20. So the vector is at what? 90 plus 90 plus 90 is 270. 270 plus 20, it is 290 there. This is our direction when we are moving clockwise. Okay, what about if you are moving anti-clockwise? Anti-clockwise, we will start from the positive x direction all the way to where our vector is. Okay, and to find this, we are going to say, because we know that from this point to this point we have 90 degrees and we have been given 20 already, so we're going to say our direction is going to be 90 minus 20 there, which is going to be 70 degrees. Okay, when you take on the calculator now, try to confirm if cos, let's here use now sine, it is only cos, which is true. Let's try sine 290 and sine 70 there. So sine 290, guys, sine 290 is negative 0.94, negative 0.94. What about sine 70 there? Sine 70 is now positive 0.94. So you can see the magnitude are just one and the same. The only difference is the negative here. So using clockwise and anti-clockwise, it doesn't affect what is the direction. Just use anti-clockwise if they don't specify, okay, the direction which you should use anti-clockwise. Okay, you move from the positive x direction there to where our vector is in this case. Okay, that's how we move. The other example is this one. Okay, the other example is this one. We still also start from the positive x direction. Let's say now our 20 degrees is here. I'll be using 20 degrees. Doesn't mean you've always been given 20 degrees. So to move now, we want to move first. We are going to move clockwise. Okay, in fact, it's the last part I'm going to talk about clockwise. To move clockwise, we start from the positive x direction. Guys, know that we measure angles from the positive x direction. So we're going to move from the positive x direction all the way to where our vector is. Okay, so as you can see now, what we need to know, we need to know that this is a straight line. So from this point all the way to this point, okay, we have 180, because a straight line adds up to 180 degrees. What about this angle here? This angle is going to be found, since this is a 90 degrees, is going to be found by 20 minus what? 90 minus 20. So this is our 70 degrees there. So now we are going to add, since our vector is heading here, Okay, we are moving from this to where our vector is starting. So I'm going to say 180 plus 70 there. So our vector, our angle now, our direction here will be 180 minus plus 270, which is actually 250 there. What if you want to move now clockwise? How can we move clockwise? Clockwise, we start from the positive x-axis as usual, then we go to where our vector is. The vector is here. Okay, so now what we do, we just had here, we already know that we have 90 and we already have been given a 20 here. So we are going to have our vector is going to be, our direction is going to be 90 plus 20 there, which is going to be 200 and 110 there, 110 degrees there. So this is how guys should be finding the direction. Okay, so 110. So even if you want, go ahead and try on your own there. Try to prove if this is true using any cosine, any trig ratio there. Say sine 250 and sine 110, it is going to give you the same answer. Okay, what if now our 20 degrees is here? How can you find the direction clockwise? Anti-clockwise. Anti-clockwise, we move from the positive x direction all the way to where our vector is. Okay, so this is a 180 degrees, guys. This line is a 180 degrees. So to find this theta, we already been given 20. We're going to say 180 minus 20 there, and you're going to get 160. This is how you go about it, and clockwise direction. Let me just also show you how to go about clockwise direction. I don't want to be blamed at the end. So our positive x direction is here, so we just move this from where our vector is. Okay, so now we already have, okay, as you can see here is a 180. It is a 180 degrees, and we are adding 20 degrees here in this case, because the vector, this 20 is what is within the vector there. So we are going to add 20, so we are going to have 200 here. Go ahead, test sine 200 and sine 160. What is sine 200? Sine 200 is negative 3 point, negative 0.34. What about sine 160? It is 0.34. This is making sense, guys. This is making sense. Okay, so let's go ahead now and do the other question. What if now our 20 degrees is here? How can you find the direction? Anti-clockwise, as usual, we start from the positive x direction. Guys, you are going to see how important this is. In fact, on vectors, what is difficult is to find the direction. The magnitude doesn't change, so students fail because of the direction. Okay, so we move anti-clockwise to where our vector is. Okay, so in this case, you can see that this part from here to here is a 180. So we're going to add 20. Okay, so our theta is going to be 200. The anti-clockwise, we move here to where our vector is. Okay, so we are going to add this part and this part. So from this part to this part, we already know to say it is 90. What about this part? We are going to subtract 90, 20 from 90, which is 70 here. So we're going to add with it 70 there. So we're going to get 160 degrees. These are one and the same. What if we add 20 here? what if you had 20 here? Go ahead and find the direction using anti-clockwise. We move from the positive x direction as usual, okay, to where the vector is. So here, what we need to know, we are going to add this and this part, okay. So what you are going to have here, it is a straight line. We have 180. What about this part? We subtract 20 from 90 to have 70 here. So we have our 70 here. So our answer is going to be 250. Okay, so let's go ahead and find the direction using clockwise direction. We move from here all the way to where our vector is there. Okay, to where our vector is. Our vector is here. We are moving. So my pen is misbehaving now. Okay, so I see, I'm sure you can see here. We are moving like this. So as usual here we have 90. Here we already been given 20. So this is 110. So it means this 110 and 250, they are just one and the same, guys. Okay, so let's say now, for example, I've been given our 20 degrees is here. This is our last part, I'm sure. So I've tried by homies, and I can tell you this, you can't be taught in class. They'll just tell you, find the only point they'll tell you in class is that you find the direction from the positive x direction. So here what you do, you move now. Okay, you move from positive x direction. We want to move anti-clockwise. We move this to this point. Okay, so we are going to add from here. We have 90. Here we have 90. Here we have 90. What about this part? It will be 70. Okay, so 90 plus 90 plus 90, it is 270, plus 70 we have 340. This is our direction. If we are asked to find the direction anti-clockwise. Now clockwise, we will move now from here to here, which is just 20 degrees. So guys, don't worry about this. These things are very simple, and the good part is that I've recorded, so you're not going to find any challenges. So it is 1946. I've only remained with 14 minutes. So let me go ahead and explain about the directions, some terminologies, and also the quadrants. Then we'll end from there. Then I'll solve the questions which I'm going to share. Okay, before now, let me talk about maybe I talk about vectors along the x-axis. I mean along the axis. Let's say, for example, if you have been told that the vector, guys, take note of this, the vector is moving along the positive x direction. Okay, what is the direction of a vector moving along the positive x direction? The direction will be 0. I mean not 0. Okay, let me just check the text here which is coming. What about the vector which is moving the x? In fact, I didn't finish talking about this. So if a vector, this is our positive x direction, this is our negative y direction, and this is our negative x direction, and this is our positive y direction. We measure the angle from the positive x direction. Now let's say they just tell you to say that the vector is moving in the positive x direction. This means to say that this vector hasn't made any angle. Okay, that's why the angle, the direction will always be 0 here. Yeah, I was just right by saying it is 0. It is 0 when a vector is moving along the positive x direction. It is 0. What if the vector is moving in the positive y direction? Okay, it is moving in the positive y direction. What is the angle? We are going to start from the positive x direction to where our positive y direction is. It is here. And you know that this angle is actually 90. So wherever you hear that the angle travels in the positive y direction, just know that the angle they are looking for is 90 degrees. So vectors, guys, has a lot of things we need to know. Okay, what if now we have been told to say the vector is moving in the negative x direction? As usual, in the negative x direction, you move from the positive y direction all the way to where our negative x is. And you can see that now this is making a 180 degrees. So when a vector is moving in the negative x direction, just know that it is moving at an angle of 180. Failure to know that, guys, you'll be unable to answer any question on vectors. So I urge you to go through this just today. Okay, so now what if the vector is moving? Okay, let's say now the vector is moving in the negative y direction. When it is moving in the negative y direction, it's meaning it's starting from here all the way to where this vector is, negative y is. And here we have 90, here we have 90, and here we have 90. So when you see that it is moving in the negative y direction, just know that that angle it is at what? It is at the 90 plus 90 plus 90, it's 270. Okay, it is 270. So guys, you need to know this by heart. Okay, you need to know this by heart. So again, about the positive x direction, you can write 0. Also you can write 360. It is one and the same if we have to move in the clockwise direction, because we will move from here all the way to our positive x direction, and this is a one revolution there, which is 360. So the positive x direction can be 0 degrees, also 360. It is one and the same. For example, try this. Say cos 0. You guys, you need proof. What is cos 0 on your calculator? Cos 0 is 1. 0 is 1. What about cos 360? Okay, cos 360 cos 360 is also 1. So this is one and the same. So when you see just the vector was moving in the positive x direction, just use any of the two angles, either 0 or 360. As simple as that. Let's do the last part now. Okay, about vector direction. Vector direction terminologies. You will hear things like northeast, northwest, southwest, and southeast. And these are the parts which confuses a number of students. Okay, so when you see the vector is moving in northeast, let me start with northeast, because here we know that it's our north, here it is our west, here it's our south, and here it is our east here. If you hear that the vector is moving northeast, okay, northeast, it means that the vector first, I'll be using the theta of 200, and I'll be using the theta over, let me use the 30 degrees. Okay, so when you see northeast here, northeast, when you see northeast, the first thing that should come into your mind, it is that the vector was in between north and east. It was in between, midway. but that angle was closer to east than to north. Okay, I'm going to show you what this means. So northeast meaning the half of 90, since it is in between, it is in the midway. The half, we know that this makes 200, I mean this makes 90 degrees. So the half is 45 here. And it is closer to east. That's why our 45, we didn't put our 45 here. Rather we pressed here because it is northeast. We follow the direction which is in the hand here. Okay, so this is how you find the northeast. So you hear something like the car traveled northeast. Okay, the car traveled northeast. Just know that the direction is 45 there. That's where vectors becomes difficult, guys. Okay, we are still on the terminologies. We have east, we have north, we also have south here. So let's say now we have been told to say let's find the vector which is northwest. Okay, it is northwest, in the northwest direction. Northwest direction, it means the vector is in between, but that 45 degrees is closer to what? To west. So this is where we're going to have our 45 degrees. Okay, but the direction here is now where you are going to combine the concept. But the direction, we measure the direction from the positive x direction. Okay, so we're going to measure from our positive x direction is here. So we go to where our vector is. Okay, so now when you just hear northwest, just know that the theta they are looking for, it will be now 180 minus 45, which is going to be 135 there. That is northwest. You shouldn't need guys to master this. Just know how to go about it. But if you are good at memorizing, you can memorize to say northwest means 135 degrees. But I don't recommend people to be memorizing this. Okay? Just understand what it means. Northwest, it means the vector is in the midway. It is in between north and the west, and that is 45 degrees to the west. Okay, what about if we still have our north here, we have our west, we have our east, and we have our south here. And the vector we are looking now for southwest here. Let's find the vector southwest direction. As usual, this vector is between southwest, but it is to the west here. It is to the west. I'm following to the west because of this west here. That's why the vector is not, the angle is not here, but it is here. So now to find the direction, we measure from the positive to where the vector is, which will be 180 plus 45, which is going to give us 225. Okay. What about this part? How can you find out the vector? North still, we have west, we have south, we have east, and we have south there. Okay, so then we are asked to find the direction southeast here. Southeast, it means the angle is in between south and east. Okay, and it is in the midway, so we're going to have 45 here. Okay, so to find the direction, you can move from the positive x direction all the way to here. Okay, and here we have 45. So here we have 90, we have 90, we have 90 degrees there, everywhere there. So it will be 270 plus 45, we are going to have 215. Okay, so now this is going to be my last part on how to find the direction. It is very, very important also. Okay, and you should pay attention here. So we have the positive y, we have the negative x, we have the negative y here, we also have the positive x. Okay, so how can you find now the direction? Okay, so let's say for example this quadrant talks about the sign of x and y components. It will talk about the sign of x and the y components. So this is the first quadrant. You guys know this already, but if you don't know, it's fine. This will be your first time to learn. This is our third quadrant, and this is our what? Our fourth quadrant. Our fourth quadrant. In the first quadrant, as you can see, the y is positive, okay, and the x is positive, because this quadrant, it is this part, guys. It is this part here. Okay, so as you can see in this part, our x, our y, if we are using vector a, our y component will be positive, okay, and our x component now is going to be what? To be positive also. What about this part? Okay, so what we do here is what we do, guys. I hope you are getting this. I hope you are getting this. So in the first quadrant, we maintain the angle. You need to know this. Maintain. Okay, let's say for example, if the theta you found was 20, and you find to say that the both x and y component are positive, the theta will still, the direction will still be 20. What about here? How can you find now in the second quadrant? What do you need to know about in the second quadrant? The y component is positive, and the x component is negative, as you can see here. So how do we find the theta? The theta here, the direction is going to be found by 180 minus the theta which have been given. So in this case, since we have been given the theta which we found to be 20, our direction will be 180 minus 20, which is going to be 160. That's why that question, guys, now, okay, let me go back to that question. Yeah, so this was the question. After we found the direction to be 61, okay, I said the x component here, as well, we were given the x component to be negative 5, is negative, and the y component was positive. That's why I knew to say that since the x component is negative and the y component is positive, that means the direction, the vector is in the second quadrant. And in the second quadrant, we subtract the vector, the direction from what? From 180. That's why we had this. So this is how important the quadrants are. I want to... Okay, so this is how what you need to know about the second quadrant. What if a vector is in the third quadrant? Just know that the x component is negative, and also the y component is also negative. But here, the theta is found by 180 plus the angle which we found. Guys, you should copy this. Copy this. So in this case, if you find the direction to be 20, then the answer is going to be 200, because 180 plus 20 is going to be 200. This is the direction we are going to use. In the fourth quadrant, just know that the x component is positive and the y component here is negative. What you do, to find the direction, just know that it is now 360 minus the angle theta. So in this case, we would have 360 minus 20, which is 340 there. Okay, so guys, this is everything you need to know about vectors. I've concluded everything about vectors. So in the next part, I'll just answer questions. I'll just answer questions now on the vectors. All the questions I'm going to answer. So don't jump to the video which I'll send on vectors without understanding this, because you'll be confused. Okay.